Hello and welcome to this edition of the education webinar that happens every Saturday at 4 p.m. By the Hindu. This week we are dealing with we're sort of drilling down to the integrity, the details, and nuts and bolts, to use a rather appropriate metaphor. It's called revamping first year engineering curriculum. It's now admission season, so there's a lot of students who will enroll in engineering programs, and they all may choose different things. And obvious preference is, of course, IT, computer science, but there's always interest in some of the what's called core engineering subjects: mechanical, civil, chemical, and all those. So engineering is such a vast draw for students at this point of time. And we thought we'll deal with so when they step into the college, they'll be faced with this first year curriculum, which is sort of common to all branches. Now that's a little bit odd, because engineering in this today's day and age is getting very specialized right from the word go. But the first year continues to be common, and some of the subjects that taught are common. They traditionally they've been, math, physics, chemistry. They learn some basic engineering of various streams. The students go to workshop and they work with their hands. That's a little different from their school. They learn carpentry. They work on forging, and and they learn how to turn a lathe and things like that. And they learn English as applied to engineering. So there are these common subjects, and there is this course on graphics, drawing, which is sort of the equivalent of anatomy in MBBS. I heard that many students do poorly in anatomy, because it's a huge, vast subject, and it's like nothing in school prepares you for the anatomy course in MBBS. Similarly, nothing in school prepares the engineering students for drawing and graphics. It's very different. But it's at the core of engineering thinking, I suppose. So these topics have been common, and they have been they sort of remained the same over the years. So Professor Siva Prasad, who's a former professor at IIT Madras, he wrote an article for us on how their first year curriculum should look like. The curriculum that's common to all branches, how it should look like. That was his theme of his article. And based on that, we are doing this webinar. We thought we'll throw it open to the public. We'll ask them for changes, comments, and we'll relay it. Hopefully the AICT is listening, and Professor Prasad has some leeway in the AICT. Maybe it will reflect there. So we have him on the panel. We also have another contributor to the Hindu, Professor O.R.S. Rao. He's he's a student at IIT Madras. He's currently Chancellor of the ICFAI University in Sikkim. He has had a long career in the industry, as well as in teaching and research. So we have these two very distinguished panelists, and so we'll start probably with Dr. Rao, who will sort of lay out the current challenges, current trends in engineering and engineering education, and why that necessitates a revamping of the first year curriculum. Sir, go ahead.
So very good afternoon and namaskar. Vanakkam to all of you. So thank you very much, Mr. Kalyan Ramanan, the Hindu, for having given an opportunity for me to air my views on such an important topic that we are talking of today. I completed my BTech, from IIT Madras in 1972. It's more than 50 years back. In the last 50 years, I have seen radical changes, if you are looking at, the industry, education, and the entire, ecosystem. Considering that, BTech is a very professional program, and the graduates, they are expected to contribute creatively and productively, because the engineering is not like other disciplines. Here, a lot of creativity is expected, and sort of a lot of kind of things, whatever we do, it is going to help the industry and society at large in a lot of ways. In view of this, it's very important to look at the developments in the last few years. First of all, let's look at what happened to the industry in the last few years. The industry, it evolved sort of with the mechanization stage in the 19th century. That is when we started off, called it as a industry 1.0. From there, the industry has, very quickly graduated to 2.0, 3.0, 4.0. The 4.0, it has come in the early 21st century. By that time, we had internet, we had mobiles, and we had, the cyber world. Sort of that is when, in the early part of the 21st century, if you take him something like, go 50 years back, 10 years back, at that point of time, with that internet, the entire focus was on there is a cyber world and there is also physical world. We are there to see that, digitization, how it is happening into that. We got to make sure that it happens into that. In the last 2 to 3 years, something more has happened. That is the chat GPT that has come and that has revolutionized the entire world. That is the kind of, coming up of, the AI, the artificial intelligence that has come, and it has changed the entire world. And now we call it as an AI world or AI age into that. Now, what is the focus of Industry 5.0 as far the industry is concerned? Yes, we have done enough of digitization. We have done enough of mechanization. Now, something called artificial intelligence is coming up. Artificial intelligence, there, it is taking away some part of our own intelligence, and that's why it is called artificial. Now, the focus is on how to coexist with the AI. The 2025, it has heralded the enrollment of AI as an employee. Is one of the kind of employees, is AI. In China, the AI and the AI robots, and now they call the humanoids, they have joined a running race. They're running along the human beings. So this being the case, now the AI is working along with us. And now the entire focus is on how the human beings can collaborate and work along with the machines and the technology. Now the new challenges that are coming up, the one aspect is the sustainability, because we got to make sure that the world is sort of sustainable, this thing is retained. The second thing is, like, in fact, whatever we do, it must be for the good of the world. And the third thing is there must be resilience, because now the entire human beings, they are coming under a lot of pressure. So many jobs are going away, the entry-level jobs are going away. With the AI coming in into that, with the result, people have a lot of tension, a lot of worry. What's going to happen to me? In this era, yes, how to coexist and work with the AI and the technology, that is the key theme of the 5.0. Now in this world, what is the expectation of the industry from the kind of engineering graduates? The expectation is not just the technology skills, which were the case until even 4.0. Now it is technology management skills. The management and the entire industry expects the engineering professionals to be T-shaped professional. That means what? You need to have depth in one discipline, but at the same time, you need to have a lot of broad skills. What are the kind of skills? The technical skills will be something like a technical literacy must be there. You need to have interdisciplinary skills so that you must know something of everything. At the same time, we should not forget the human skills. What are the kind of human skills? Which we call it as a native or natural intelligence, not artificial intelligence. That is the creativity, critical thinking to solve the problems, and communication. When you say communication, it's not just speaking English. I must be able to communicate and orchestrate my ideas, so that I should be able to kind of implement technologies and enable a digital transformation. It also requires a mindset for a continuous and lifelong learning. Gone are the days when we say that I know everything. Every day things are changing. So every day I got to continue to be student. Sort of these are the kind of things what the industry is expecting. Now let's look at the learners and students. Yes, sort of I go back and see what I was at that point of time. When compared with that, today the students are smarter, more energetic, tech savvy. All of them are born in the internet world and mobile world. They are all learning by themselves a lot of things because a lot of opportunities are there. But at the same time, they are very time conscious. You ask them to do something, they say, what is in it for me? If it is relevant for me, I will learn it. Otherwise, no. Low attention span. The attention spans have come down to something like minutes and seconds into that. Very high aspiration, yes, understandable, but at the same time, instant gratification. I want something immediately into that. Impatience, lower resilience levels, that is what reflected into a lot of mental health issues that are there, leading to depression under pressure. We have seen my alma mater, like IIT Madras, IIT Delhi, lot of suicides that are coming in terms of that, including the premium institutions. Today, that's the kind of a world. In this world, particularly when we are looking at the first year of the BTech, the first year of BTech is a very important year. That's the time when the students transition from schooling, where you got a parental care, very close monitoring. From there, they come into so-called an independent world. The perception that is there is I'm becoming a free bird, independent into that. Yes, I want to kind of make my own career, my own life in terms of that. But at the same time, a lot of students have seen their understanding of what is a career, what is the kind of what is that I want to do, that is relatively less. Most of the time, decisions are taken under peer pressure. So with this environment, the first year of BTech, which is the foundation for the not only for BTech, foundation for the career and the life of the students. Sort of now, I think we got to relook at the structure of the first year BTech, and which was sort of I have seen in the last 50 years, it hasn't gone radical changes, because the same kind of physical sciences courses that are there, same drawing that is there. Those days we used to go with T squares and set squares and all the kind of things into that. But today, are they all required? Similarly, like in fact, all that kind of the mathematics we were learning so much of that, is it all required into that? I think today there is a critical need to examine this and see the relevance of that, and see that we set a kind of a tone for a revised kind of curriculum structure and the pedagogy and way of learning. That's where the kind of importance of this topic. Thank you very much for giving the opportunity for this. Sir, you are muted, sir.
Sir, Kalyan Raman, you are in mute. Yes.
Yeah.
Thanks for pointing it out. Okay, so thanks, Dr. Rao. That was a very succinct, nice piecing together of the context for why we are doing this. And just to let you know, very interesting questions are already coming. People are posting. But I will have Dr. Siva Prasad to tell us about this, because the whole webinar's idea came from his article, in which he had very clearly marked some of the differentiating aspects of what he wants in the current, in the new or revised first year curriculum, vis-a-vis what we have seen in the past. He had talked about graphics and very, very interesting and important changes that he has suggested. So go ahead and give us an introduction, give us a, and we will go into the questions soon after that. We are seeing some interesting questions. Oh, by the way, the best questions will get we don't know how many, they could be 1, 2, 3, 4, we don't know. Valuable questions that provoke good answers, interesting, insightful answers, will get a free subscription to the Hindu Online. So please go ahead, keep posting comments, questions. We'll keep asking our panelists those questions. So meanwhile, yes, Dr. Siva Prasad, please tell us.
Thank you. I thank the Hindu and also particular Mr. Kalyan Raman to take this initiative to bring it to the larger audience, and the importance of meeting with the current requirement in studying the first year courses. That is the objective. Now, I'd like to take the subjects, what is the content and what is that is required, so that people hearing will be able to identify the existing curriculums suggested by AICTE, and also what is that it is required in the current scenario. If I take the chemistry, atomic molecular structure, spectrometric techniques, intermolecular forces, use of free energy, periodic properties, stereochemistry, organic reactions. Only I'm studying, I'm reading the broad outline. And similarly, when you go to the physics, AICT suggests 4 physics courses. And in the 4 physics courses, what is that it is given is uh, introduction to electromagnetic theory. I don't go into the details. That is one subject, introduction to electromagnetic theory. And then second course is introduction to mechanics. And the third course is introduction to quantum mechanics for engineers. And the fourth course is oscillations, waves, and optics. The students can take any one of these four courses. Now let us see that what is that it is required either in the chemistry or in the physics before we go to the other subjects. Today, we require in the physics, for example, civil engineering, properties of materials, geophysics, soil physics, environmental physics, oscillations, waves and acoustics, optics and laser applications. In similarly, chemistry, material chemistry, cement and concrete chemistry, water chemistry, corrosion science, polymers, and the composite materials. That is what is required. Similarly, if you take a mechanical engineering, kinematics of particles, material science, nanomaterials, thermodynamics, oscillations of waves, vibrations and acoustics, engineering of optics and lasers, chemistry, thermochemistry, fuels and combustion, engineering materials, lubrication and surface chemistry, corrosion and protection. Electrical engineers require semiconductor physics, devices, electromagnetic fields, oscillations, waves, AC fundamentals, quantum principles, optics, and photonics. Similarly, electronic students require semiconductor physics, optoelectronics, fiber optics, electromagnetic theory, quantum physics, analog and digital sensing physics, computer science, digital electronics and semiconductor physics, electromagnetism for circuits, devices, quantum mechanics, photonics and future technologies, chemistry, materials for computing energy, etc. If you look the modern student, what he requires in the subjects that are likely to come in the higher semesters, you see, the current syllabus in many of the universities, it is unique for everybody and not able to meet the requirements of different branches. This is one of the things which we have to address. The physics, rather than calling chemistry, rather than calling it as the basic sciences, I prefer to say that these are the foundational courses for the upcoming courses in the higher semesters. When you look into what are the courses they come across in the higher semesters, what are the topics that are required, rather than one chemistry and four physics, one of the four you have to choose. Combinations in these four subjects are what is required for most of the branches in the engineering. After coming out of the engineering, I would like to address the workshop. Many of the universities in the workshop, carpentry, fitting, and the related ones, smithy, foundry, these are the experiments which you find. Sheet metal is one more. These experiments were set maybe 50 years ago, 60 years ago, when most of these current branches are not there. In those days, it's only civil mechanical, not too many of the developments. Lot of developments have taken place from industry 1.0 to industry 4.0. And then we are seeing that still we are teaching them the skills that were required long time back. So here, this is required to relook into what is that it is required today, students. The workshop is a skill-based one. In some of the colleges I have seen, they demonstrate maybe how to operate a lathe by seeing how a music is played by a guitar artist or somebody we never learned. The skill is the one which you have to practice by hands. So these are the workshops that are required today. Everybody requires to know how to operate a computer. Many people might not be knowing how to connect a printer to the devices, any other devices, and similarly how to go into the cloud or how to install a particular OS or operational the software, and how to see that protect it from the virus. And similarly, today world is the electronics world. People should be able to identify the components of the electronics and know how to solder and how to bring them together and how to connect it to the IoT. That is what is required in the industry. So we are nowhere nearer to what the industry is looking for. The industry one way always tells us the graduates which are coming are not suitable to the jobs. That is what people are saying in the industry. But we at the colleges are not able to revise our syllabus in tune with what is the requirement of the university or industry. And another subject, graphics, engineering graphics. Engineering graphics, still in many of the colleges, they go with the mini drafter and also the set squares, etc. No industry is using the manual drawing. Today, everything is computerized. And we are not able to introduce what is required in the university for the future manpower requirement in the industry. Here, again, I will go into the plane geometry. Usually, we call it as the curves, maybe hyperbola, parabola, ellipse, and then cycloidal curves, etc. All these construction procedures were there when there was no computational facility that was available. Graphical methods we are adopting. Even though we call it as the engineering graphics construction, the curves, etc. Today, by a simple program, you will be able to get any of the conic sections and also the cycloidal curves, etc. We have to go into how to program using any of the softwares, or if the software is already built, how to use to get the curves. That is what is required. The skill that is required is how to get the curve and also integrate it in the future designs that are likely to come. Then I would like to touch upon the new subjects that are emerging. The three subjects that are emerging are AI. Today, as Dr. Rao Garu was mentioning, AI became part of our life in every arena of our livelihood. So AI has to be introduced in the first year of engineering. AI tools. I don't mean how to develop AI algorithms, etc. That is in the higher semesters by computer science specialists. They do. We use the word. We should know how to use the word, not necessarily how the word software has been developed. So here, AI is giving a lot of information in the learning process. We have to introduce AI tools and their applications is one thing that is required. And the second thing that is required is what I have noticed. The C and C++ is what has been recommended in the current curriculum, model curriculum. And my observation is many of the students are by-hearting some 20, 25 programs and get good grades. And in the final year when they come, or third year when they come, most of the institutes arrange a training program how to write a computer. Even computer science students are undergoing the training, whatever scenario it is. In the first semester, instead of going into the syntax and the grammar of a particular language, we have to introduce how to develop an algorithm, how to break the problem into simple steps. That is computational thinking. Even the schools, it is being introduced in many of the countries, at least in the engineering, till the schools introduce, we have to introduce computational thinking. And in the computational thinking, how to divide the problem and how to develop the flowchart, algorithm, pseudocode, and then to check whether his thinking is all right or not, we do require a code. And that code, a simple thing is today Python, very widely used in the first year in place of C or C++. We have to should call that one as the problem solving. That is all. And using maybe Python is for testing is one thing. And the third course which we propose is design thinking. Today, industries are coming up on their own. Many of the people are incubating. And also, design thinking tells the empathy and also the steps to meet the requirement of the industry. Either it is a software development, electronic hardware development, or mechanical engineering hardware development, or even if you go to the management principles, this is an absolutely essential subject that we have to give it in the first year, along with the other subjects like physics, chemistry, etc. The other one, I have already indicated about the workshop skills that are required, and the mathematics. Mathematics, most of the universities offer mathematics 1 and 2 as a common subject. There is nothing wrong. All the principles that are required, like differential equations, matrix algebra, etc., are required. But I believe we have to train how to use the softwares like MATLAB or Mathematica. What are the problems they are using the hands-on time to learn that? they should verify with the MATLAB kind of a tool we have to expose, because when he goes to the industry to solve these problems, people should be trained how to use the tools. These are the tool. And the second thing is, we never give the example problems that are coming from the engineering. We just like abstract mathematics we teach. From the abstract mathematics, when it is to be applied to a particular problem, the conditions will come. The student is finding it difficult to come back to apply to his original problem, whichever is the one which we are telling, subject which we are saying. Now, the branch specific examples have to be given along with the mathematics 1, 2, and the 3 and 4, whatever it is. These are some of the things. And the communicative English, and in some of the universities I have seen prose and poetry are given in the communicative English. No doubt, coming English is LSRW is the absolute requirement. Along with the LSRW, what is required in the engineering, like report writing, then debating, and also a lot of AI tools have come in learning the English. We have to expose our students to the latest tools in communication. That is what we have to do. I think these are some of the changes that are required in the present engineering curriculum. Introduction of the modern thinkings like embracing digital fluency, computational thinking, AI tools, and design thinking and innovation. And in the workshop, basic electronics and basic computer science related ones, along with the basic mechanical assembly tools. Because if he has to make some model when he comes into third and fourth years, his own design project, etc., hardware design, you should know finally fabrication techniques that are being used in the mechanical engineering. I feel that I have covered what are the latest things that are required. Now we can open it to further discussion. Thank you, sir.
Sir, can I say something on that, sir? Yeah, yeah. So, Professor Shiv Prasad Garu very clearly went into a lot of details of the curriculum and, orchestrated, what all the changes that are required. I'm in full agreement with you, because I have been in the industry for about more than 25 years. I was in the industry, both in the manufacturing and particularly in the IT industry. I was there for more than 20 years. I have recruited, hundreds and thousands of students at various levels. And after having seen that and tried to relate with, what we learned, a few thoughts that cross my mind is, number one, the foundation courses of the BTech, they were designed long back. At that point of time, the career that was expected from these graduating students is, it is a core engineering, either designing a product, manufacturing a product, or maybe go through the entire life cycle of that product into that. But in the last, and that too, like in fact, at that point of time, the courses that were designed designed in such a way that, ab initio, from ground up, I must be able to kind of think of a product, and I should do something like maybe design calculations out of that, fundamental design calculations using applied mechanics. Then after that, I must be able to build the kind of a models, stress the kind of a models, and come with the final product. But now the world has undergone a lot of changes into this. The first thing that has happened is, if we take care of the manufacturing industry, like in fact, most of the careers people aspire, they are not hardcore, the engineering, design, and manufacturing into that. Maybe a few of them go into that. Then the second thing what we notice is sort of a computer science, particularly in the last about 10 years or so. Most of the engineering colleges, if you find, something like more than 80-90% of the students are with the computer science or allied courses. Computer science, AI and DS, or cloud computing, and all these kind of courses into that. If you go back and see that, what is that all the students learned in the first year? They learned more and more of mathematics. Yes, sometimes it may be required for algorithm design, but they learned chemistry. They have learned some chemistry up to class 12. After that, they go into physical chemistry, organic chemistry, inorganic chemistry. Is that all required? And so much of mathematics is it required? And similarly, like in fact, engineering drawing, Those days we used to go with set square, T square with a drawing paper and draw the orthogonal projections and all of them. Are they required now? Is that how the design is being made by the companies today? It's not. Today we've got CAD tools that are there, and you don't need all of them at all. So to that extent, the first thing in my view is like we also have to look at what is the career that somebody is expecting out of the engineering. Because if somebody is going into mechanical engineering, electrical engineering, or maybe chemical engineering for few, the kind of the foundation course that may be required is different when compared with somebody that wants to go take computer oriented courses. They are not doing any kind of a hardcore design of the products into that. The grounding what they require is different. Second thing is there are some students that want to go into something like hardcore engineering or computers into that. Some of them may like to go into research, or some of them may like to become an entrepreneur. Depending on their career aspiration, the foundation course has to be different. So to that extent, like I saw some of the comments that are coming from Professor Visham and other people, sort of maybe that is where sort of going beyond the curriculum. It is structure. If you are looking at the kind of a structure for the first 2 semesters, today it is compulsory. Should it continue to be compulsory? Can't we have electives? Possibly what you may like to do is some part of the kind of a common courses could be there, which is required for everybody. If you ask me what are the things that are required, something like a digital literacy or real literacy is required for everybody, whether it is a computer science or otherwise, because it is part and parcel of our life. So to that extent, something like, a technology literacy of the various kind of technologies, embed them into concerned disciplines. That is one part I think everybody must know. A computational thinking or a design thinking that is very, very essential, because today, not only in the industry, everywhere, somebody must know on how to think critically and solve the problems. Third thing is, today the industry says that sort of so many things AI is able to do. What is that AI cannot do? AI is not creative. The creative thinking has to be there. Creative thinking, sort of critical kind of a problem solving into that. These are the ones that have to be embedded. That is where today there are courses on design thinking, systems thinking into that. That kind of a courses, if they are embedded into that, that will kind of encourage and motivate our students to start thinking rather than memorizing and sort of vomiting into that. So to that extent, in my view, something like a digital or technology literacy must be a compulsory kind of a course. Second thing is something like critical thinking, and this kind of a thing is very important. Third aspect is, in fact, one of the participants very rightly observed. Today we are talking of careers and salaries into that. What happens to the basic character? Because when we were students at that point of time, character building is a very important thing. It used to start with the kind of parents in the schools, but now the character building doesn't happen in the education institutions. So with the result, like in fact, that's what Swami Vivekananda said. What is the education that you want? The education that you build a character. A strength of character is something that is a foundation stone that is required. Today, like in fact, the students, like very small little things, they get tensed up and, sort of they become, very, very fragile. They something like, their mental health is getting spoiled. They get depressed into that. So that is where the strength of character has to come. So that's where I think life skills is something like what you may have to put into that. So if you ask me, I think these are the 3 types of courses I think we should make compulsory. And maybe some mathematics definitely you may require. The rest of them, possibly, you may call them as electives. That is where I have seen my alma mater, IIT Madras, 2024-25, they have revamped the first year after several years. What they did was they said 40% of the kind of credits, now they made electives. That is where I have seen that life skills, similarly like something like, communication skills, and sort of social activities like NSO, this kind of a thing. They also introduced a very, very innovative course called the kind of, recreative kind of skills into that, recreation into that, so that the kind of a tension, mental health of the students is taken care into that. What I noticed is 15% of the credits into this kind of, life courses. And maybe some part of the courses will be only the compulsory. The rest of the electives they depend on the career somebody is aspiring for. I think if you do that, in my view, I think that is going to help the students to navigate the future.
Got it, sir. It's interesting that there's engineering students are still carrying the mini drafter and set scores. I didn't expect that. I'm surprised that they still do. Uh, yes, I think Dr. Professor Shiva Prasad did mention about basic computer knowledge that should be given to everybody as a workshop. He was actually saying that in his presentation. Well, meanwhile, we'll read out all these questions. They're very interesting,
Sure.
insightful questions that are coming. I'll start with the first. Vishwam T. He says he's a professor at the Hyderabad campus. Campus of what? IIT. Okay. Based on my 15 years of experience teaching engineering physics, I've observed that many CSE students, computer science engineering students, find traditional topics like electrostatics and magnetostatics less relevant. Revising the curriculum to include computational physics, quantum computing, and photonics to make them more aligned with future academic and professional needs. The engineering physics syllabus should be discipline specific rather than a common syllabus for all branches.
That is what I was also suggested the topics of each branch, what is that required. The course, in the sense, it is not that out of 4, 1 has to be taken. It is the combination of the physics which have been suggested by the AICT, and the departments have to decide what are the onward subjects in the 2nd, 3rd, 4th year. Based on that, we have to find out what are the topics that is required in the physics. That is what Professor Vishwam was mentioning, I think. Good.
And Vishwam T continues, he says, lab experiments should align with syllabus content, encouraging student engagement rather than focusing only on attendance and marks.
Right,
Okay.
sir. And that is also one observation. The AICT model curriculum, the chemistry, what they have given syllabus and the experiments are different. In similarly, physics also, experiments are different from theory. They should be aligned. It is a good observation by Dr. Vishwam.
Here's a common question, sir. Should there be a common first year at all? What do you think? If somebody has asked this question, I thought it's relevant. Should there be a common first year engineering syllabus?
Sir, the common in the sense, mathematics, for example, the basics are similar, applications are branch specific. Similarly, communicative English, workshop, the 3 computer-oriented courses, just now we spoke about computational thinking, AI, and design thinking, etc., are common. So most of the subjects are common. As Professor Rao was mentioning, the department-specific physics, chemistry can be in the department-specific. Otherwise, they are mostly common.
Okay, can I say something on that, sir?
Yes, sir.
So
Yes,
in
sir.
fact, as far the commonality is concerned, like whenever we design a product, we go with certain assumptions of what the product has to satisfy. Similarly, the BTech is a product. When the BTech curriculum was designed, at that time the premise was, like all these kind of engineering graduates, they must go and sort of design some products, manufacture some products. But today, the hard products, how many are designing? Today it's not required at all. If it is going to be more of an AI world, for instance, sort of Dr. Vishwam has asked a question. If you take a computer science student, like the student, up to class 12, they have gone through a lot of mathematics. Because my granddaughter, she completed, sort of a class 10. My grandson has completed class 12. I've seen their syllabus. The syllabus that is covered in mathematics, physics, and chemistry up to class 12, which is the qualifying exam for all the engineering, this syllabus, the standard levels have gone up there. With the result, when they come to the BTech, what I noticed is, with regard to the curriculum, there's a lot of commonality and overlap. First of all, we got to examine and see that all that is it essential for them. Or is it something, maybe supposing somebody wanted to go only for, a mechanical engineering or a civil engineering, for them it is essential. But for somebody that wants to go into the computer science, is it essential? So to that extent, this kind of, the structure of is something like a compulsory and electives. What IIT Madras has designed, 2024-25, they have done it after a lot of thinking and a lot of deliberations. For this, they have discussed with a lot of people from industry. They discussed with a lot of alumni and lot of educationists. They also looked at the kind of a curriculum, not only India, but also abroad. After that, they arrived at the kind of a design of something like, there should be some electives and they should be common. The common courses need not be the foundational sciences courses. So much of science we have done. Sort of today, the industry is looking for product designers. For this, more than the technology, what is required is the design thinking, a creativity, out of the box thinking into that. This is something that we should allow them to think and come out with some kind of ideas into that. So the second thing what I noticed was, like in the case of IIT Madras, I'm sure that they have done it with a lot of deliberation. In the first year, two subjects they removed. Which are these two subjects? One is the chemistry, second is the engineering graphics, engineering drawings. These two were removed. Because this is something that I noticed across. There are lots of other universities, both India and abroad. They noticed that, the chemistry, what we learned up to class 12 is good enough. How much of chemistry we use, in the design of the products is not so much into that. So to that extent, what they have done was, because they have to create a space for the other courses like a design thinking. Like, I looked at the kind of a courses of MIT in US. There, what they have done is they brought in something called a computer science for all. There, they brought in all the emerging kind of, the IT and AI technologies, which is common across for all the disciplines, whether or not AI into that, AI into that, Sort of similarly, a design thinking kind of a course that is common across into that. And another thing, what I noticed in the case of MIT was, like they have taken cognizance of the fact that a lot of students, when they join first year, they may not know sort of each one of the kind of the core engineering. We are forcing them to take a branch by the time they join the engineering. They may not even know that. There in MIT, what they do is they allow the students, they do something called an exploration of the engineering. There, what they do is they expose them to the industry. They expose them to the industry professionals. And they allow them to explore and see, yes, what is mechanical, what is electronics, what is chemical, what happens where. That is when they are allowed to take a decision on the branch after a lot of exploration. In India, it doesn't happen. So this is something that possibly we can incorporate so that, a student decides on the branch or the career after understanding what is what, rather than sort of taking a decision on something and later, he or she finds that, it's not interesting to me. So this is yet another thing, maybe I may like to call into that. Second thing, what I noticed was the way we are kind of, the students are taught. Still, it is something like mostly theory. See, something like physics course, if you can sort of teach the course using simulation in the YouTubes today, that will be a lot more impactful rather than going through the chapters and theory into that. So likewise, I have seen some courses in MIT and Stanford. They are combining something like programming languages along with the computational thinking. They say computational thinking with Python. So this kind of a courses are some places what they're done was calculus and Python. So there is more of an application-oriented courses. To that extent, maybe the building blocks, the courses, I think they may require an innovative design. We are taking for granted that there was a course on chemistry, we continue with that and change the syllabus. There's a course on mathematics 1, we continue with that. Instead, what I'm recommending is we got to innovate and maybe kind of come out with a new design of the entire the first year. And the courses also, they require some re-engineering in a big way rather than taking them as such and doing some tinkering, adding something or subtracting something into that. Likewise, I looked at the IIT Delhi is the second kind of the IIT among the first generation IITs. that have done radical changes. The changes what they have done is from the current year, 2025-26. There again, what they did was they brought in the AI literacy and courses into that. What they did was they brought in sustainability as a common course across all the disciplines. Today, whether it's mechanical, chemical, electronics, computers, everywhere, sustainability has come to stay in a different ways into that. So they brought in sustainability everywhere into that. And another thing a lot of kind of universities have been doing is, in India it started, abroad also it is there. There is something called a major branch and there is something called a minor. So now, like somebody starts mechanical, somebody stuck with that. Instead of that, to give a flexibility, if a student is allowed to have, a major and minor, the minor can be another branch of engineering. Abroad, what they do is the minor can be non-engineering also. Minor can be something like management, minor can be finance, minor can be kind of anything else. This is because when I made an analysis of the placements of the IIT students, the good careers and good placement careers, they are not into the hardcore engineering, not even in the IT. They are in the financial services. The algorithmic trading, that is where they take the engineers. So that's where they need to understand not only engineering, but also finance into that. Today, like a lot of IITians, they are into the Niti Aayog, they are into the economics. So this being the case, we should not straitjacket out students saying that, after this, you will do only the engineering. You should allow them a career of their choice. So to that extent, when once you give a flexibility to them, something like a career choice, major, minor can be anything into that, In the another kind of a thing, what we have seen is in the recent, war has shown the drone engineering is going to be a big discipline. Defense technology is going to be a big discipline, which is a interdisciplinary into that. If somebody wants to get into that, the foundation what you have to lay has to be different into that. So these are my views, So over to Kalyan Ramaji.
Yes, sir. We do have several questions. We usually go over all these questions. So there seems to be something about some consensus against chemistry here. Many are asking why this when it's already taught in school. I suppose what I'm getting from both of you is that we should identify some mega trends, like as Professor Rao was saying, quantum computing, or as IIT Delhi seems to have done, sustainability. These are some bigger trends that are going to matter, and perhaps they can be and of course the whole introduction of AI has I mean it's sort of it only syncs with the general trend of technology where sort of the lower level nuts and bolts work, the kind of routine work, rote work gets mechanized, automated, and then you move on to higher levels. So AI is keeping with that trend, and so currently there's a lot of work that AI can do, and so there's higher order thinking, creativity, design, those aspects. And Professor Shiva Prasad keeps talking about design thinking. I suppose these are some broader trends that may go into those who make these curriculums, I suppose. We'll move on. Dr. Ramarao Gollamudi. He's saying modification of curriculum over the years undoubtedly helped to impart knowledge to the students, but very little has been done to make changes in the approach to give education to imbibe national character. The so-called education looked at only is only getting at placements jobs that he needs. At the cost of placement, ethics, morals, and values are being sacrificed. Okay, we move on. More questions. Motahar Raza. He's teaching mathematics to BTech students. He's been doing that for 24 years. He's saying, as we revamp the first year engineering curriculum, I propose restructuring math content to align with AI, ML, and data science by emphasizing linear algebra and statistics with real world applications, introducing discrete mathematics early to support cybersecurity. Dr. Shiva Prasad was talking about how cybersecurity should be incorporated as a workshop. I mean to keep safe against virus and so on. And he has three suggestions: connecting math to core engineering domains. I suppose the math does get used later on, but when you're learning math in first year, you don't really quite get the connection, the Fourier transform, all the differential equations. But they are connected to engineering, but you don't get a sense of it when you're learning it. So he's saying make that connection. He's saying. Maybe flash that. Mutahar Raza. Okay, those were his. Rajesh Kalyana Sundaram. Elaborate practical applicability of the new trending branches of CSE, topped up with AI, ML, data analytics, IoT, and cyber security. Question to Dr. Professor Rao: do you feel with the mass of college students coming are going to be? I don't quite understand what he's saying. Saurabh Sinha is saying we need to first attune our faculty with what industry needs, sorry, so that they can accordingly guide students. Vocational training should be provided to faculty in the industry. Okay. During the vocational training of students, these trained teachers should assist students. Train the trainers. Go ahead, sir. As I'm reading out questions, if you feel like intervening, just go ahead. Does the need of industries so much, or will the available industry need to be catered by them? Okay. Dr. Ramarao Gollamudi. Students should be encouraged to undertake projects that extend beyond academic or industrial goals, focusing instead on social issues to foster empathy and civic responsibility.
Can I say something on that, Mr. Kalyan Raman?
Go ahead.
Referring to the point, I have seen some courses, both internationally like MIT and Stanford. They have got a course called AI and Society. Today, what's happening is, particularly when the human interface with the kind of AI is becoming so critical, like, on how the AI must be integrated with the human beings and the society, and looking at the ethical aspects, sustainability aspects into that, I think those things are becoming very, very important. That is where this kind of interdisciplinary courses, they become very, very important. Likewise, another kind of, suggestion that came from Dr. Ramarao was, in terms of, character building, the students, I think, we need to kind of, enable them to work on various societal projects through NSOs, NSCs, and NCCs, all that, sort of this kind of this thing, they will enable us, to take up, some kind of a social projects into that. Go to the society, go to the various people and find out what are the problems, issues, sort of build an empathy, try and solve some real life problems into that. I think that kind of a thing will help. Another thing as a common kind of a course is what I have seen internationally in India is, like what we noticed is, while the students come up with a lot of awareness on various things, two areas every human being must be very, very conversant and aware of. One is the health awareness. Most of us, like in fact, unless we fall sick, we don't know what's happening. So to that extent, internationally, it is believed that a health awareness starting with biology, getting into health. These kind of courses are important. In ICFI, we are planning to introduce a course like that. We are in touch with one of the organizations, something like they're building a lot of healthcare awareness. Sort of for the engineering students, we are introducing a 2-grade course on biology going up to healthcare, going up to emergency kind of a medical care. That is one thing we found to be very, very useful. It is useful not only for the students, to help somebody else. The second course I found very, very useful is the financial literacy. Because ultimately in our life, we want to make money. We should know how to kind of, maybe spend money. And sometimes we also must know how to multiply money using, ethical means into that. So these are the courses, what I've seen internationally, they find that, a student is part of the foundation courses in terms of they are all the life building or life making courses. As Swami Vivekananda said, the education must be life making. You need to equip them with the skills so that they stand on their own feet, both professionally and sort of spiritual and psychologically. I think these are the kind of things we got to do. And I saw somebody joining from IIT Hyderabad. IIT Hyderabad, in fact, Professor Desai is a very good friend of mine. One new thing what they introduced was, traditionally when we talk of courses, the minimum credit is 3 or 4. IIT Hyderabad is possibly one of the first few universities in India, institutions to come out with the micro credits. There they have got courses of something like 1 credit, 2 credit. Now you have 0.5 is there. In this process, as I mentioned, when we want to shape our students as a T-shaped kind of professionals with the lots of courses, every course may not have 3 credits or 4 credits. It can be 1 credit, 2 credit. And also some courses we should allow the students to learn on their own using the MOOC platforms, because today's students are smart. So to that extent, on the electives, some courses we can allow them to learn on their own so that the kind of a load on the distinct faculties will come down. That's all what I want to say.
Okay. Um, Anup Gupta will flash this question. With mathematics, physics, and chemistry teachers, they teach these. Well, the science teachers, they're not really engineers. So, how do we make them teach engineering? Isn't that an issue? Isn't that the issue? When they teach math, physics, chemistry, how are they able to integrate it or show to the students that what they're learning is directly connected to engineering? So he's asking that question. So they teach these subjects in a traditional way. That means theory only. No examples are given related to engineering application. We get science teaching engineering. Teach
It is a
engineering
good
science.
question, sir. It is related with the sciences, including the mathematics. The teachers in the mathematics are basic sciences, mathematics, physics, chemistry, have to be exposed to the practical problems related to their basics. I have observed that a PhD person in physics, he may or mathematics, he does some research work. When we ask a simple application problem, how you solve this problem using your PhD thesis, he is not in a position to answer that. So it requires molding physics and chemistry, those who are joining in the engineering faculty, a orientation towards the problems related to that. That requires a reorientation with the faculty, and the teachers take example problems using the basics, what kind of a problems in engineering can be solved. The student will get interest in the further in that subject is my feeling. Thank you, sir.
Just adding to what Professor Sivaprasad has mentioned, the first thing is for the BTech students, the physics, the curriculum is not the same as what is taught, for a degree colleges, either for BSc or MSc. This is called the engineering physics. In the engineering physics, essentially the curriculum itself is centered more on the application of physics for the real life problems into that. The second thing is, I think, like to that extent, the curriculum and books are also different. And now that we have got lots of tools like YouTube are available, sort of lots of visual tools are available, on how to teach engineering physics, giving them real life examples. So maybe either in terms of the YouTubes, or maybe you take in terms of, the various, the MOOC kind of, courses that are there, like Coursera. Sort of these courses, they are all meant for physics courses for the engineering students. The third thing is, maybe even though like from the industry, some of the people that have been, practicing and designing various products, if they can come and take some lectures for the students on how they design products and using the kind of physics principles, that is another thing that will help. Then the fourth thing is, like, in fact, today what happens is, as rightly mentioned by Professor Shivaprasad Garu, somebody completes MSc, PhD, qualification by this should fine, then they come and join the kind of, the faculty. But today, for a lot of faculty, they don't have industry exposure. So to that extent, like, in fact, I'm aware, I was talking to some people in IIT Kharagpur, they were trying to experiment with, the industry immersion for the faculty members, because we are expecting the students to learn hands-on into that. But if the faculty don't have the hands-on skills, how do they do that? So they try to work out a scheme whereby during the summer vacation, they said, all the faculty members, they should go for industry immersion. They should go to the kind of industry, spend a couple of months into that, looking at, how the kind of industry kind of problems are there, whether it is physics, whether it is chemistry, whatever it is, and how the problems can be addressed. When once they come back from the kind of industry immersion, in my view, I think, they are better off. They'll be able to relate the industry problems much better to the physics principles.
Interesting point. That someone did ask about training the trainers. This specific thing, I suppose it's good that somebody is doing this. Dr. Ramarao Gollamudi, he is asking projects related to social awareness could be such as controlling the traffic at a signal for a day, spend a day in an old age home to serve them, visiting orphanages, spending a month with a farmer in a village. I believe such experiences will motivate the student to design or do something to alleviate their suffering. I mean, the general point is that engineering is very technicist. I don't think, like you mentioned, sustainability, but I don't see. I maybe I'm wrong, but I don't see engineers being exposed to what impact engineering has on society and how those trends are influencing. These are not value neutral things. Any technology creates some skews. Somebody benefits, somebody doesn't. I mean, that awareness is never inculcated in engineering. What do you say, sir? It's a broader aspect. It's very troubling because when you go and work, you see that everything has an
Sorry,
impact.
but I fully agree with you. Sort of one aspect is, with regard to social work. See, when I was the vice chancellor for one of our universities, what we did was we had a tie-up with the Ramakrishna Mission Ashram. There, as a part of our summer internship, we sent our students to the kind of villages. We have given them rural projects, so that they should go and understand what happens there and some real life problems and how to address that. That was, let me tell you, very rewarding experience for us. These kind of programs and the kind of projects were designed by Ramakrishna Mission Ashram. That was a collaboration between an NGO and us into that. A similar kind of a thing, a lot of other universities are doing. Then the second thing is coming into the sustainability. Today, the sustainability engineering is a huge interdisciplinary discipline. They're starting with all the core engineering disciplines, plus the social sciences they get into that. And they today, like in fact, the sustainability engineering, like in terms of the application, in terms of jobs, everywhere it is there. Today, starting with the design of a product or opening a mine, for the kind of an area of the coal mines, and going into something like a bank where, something like a project has to be evaluated by the engineers. Everywhere sustainability is very important. So to that extent, the sustainability engineering or sustainability in engineering has come a long way. But I agree with you that in the Indian kind of education, still it has not taken roots. There, as a matter of fact, the UGC has, made it mandatory that the sustainability must be an integral part of your course. And there, what they did was, something like, as far as the undergraduate programs are concerned, they said there should be minimum credits whereby there's a foundation course on sustainability, which is common across all the disciplines. Second thing, what they said is we should have a course on the sustainability specific to the branch of engineering. And they have given guidelines for that. I think, if the university complies with that, sort of there, Mr. Kalyan Raman, I think, there will do a lot of justice to the sustainability for the mankind and also for the professionals.
Srinivas Cherukuri, he's sort of playing a devil's advocate. He's saying while transitioning to CAD software for 3D modeling and parametric design is crucial, how will the curriculum ensure that students still develop a strong spatial reasoning ability and fundamental understanding of technical drawing principles? They should still be making parabolas and hyperbolas and all that. That's what he's saying, sir. What do you think, Dr. Shiva Prasad?
Yes. See, it is not that the manual drawing will give the spatial imagination. Spatial imagination that is a 2D plane. 2D plane is a paper plane or computer plane, does not matter. We are not removing the required that is required for the spatial visualization. We are not removing. Only we are suggesting you use the software tools to get that 2D imagination quickly without losing the time. And the spatial imagination is required. 3D objects to be looked into by a 2D plane is a spatial imagination. Not at all we are removing that spatial visualization on a 2D plane. Computer screen also is a 2D plane.
Okay, so it's
Sir,
not that
I fully agree with
only
Professor.
mini drafters and set squares will provide that. Okay,
Yes,
so
Only
you're
sir.
saying
my contention was, as I have initiated in the beginning, a curve to be created, a parabola or hyperbola or etc. We need not to go into how to create the curve by geometrical construction. If I know the equation of the curve, I'll be able to get the curve and I'm able to imagine. There is no need to do it by hand. So, by hand in the sense, by practical construction, geometrical construction, these are where the computational methods, CAD softwares are giving the visualization quickly to get into. And in fact, we'll get a better visualization, complex pictures in a 3D. 3D can be visualized in a 2D plane quickly compared with the manual drawing.
Just to add to that, sir, in fact, I have done a lot of work in the CAD and CAE. Like if you look at tools like, sort of there are, sort of a solid modeling and there are various simulation tools that are available. You take tools like, CATIA, you look at something like Pro Engineer. There, as you rightly mentioned, it gives a lot of facility for the parametric engineering. There a student like can play around by changing the various parameters, and the how the kind of a solid, a three-dimensional solid, and how the what are the changes it undergoes. That is what gives a very good visual experience into that. To that, if you can add the VR, it gives an excellent kind of an exposure, which is much better than what we were studying in those days with something like a two-dimensional drawing. Those days, like in fact for us to draw something a three-dimensional was more or less very impossible for us, even though we tried to do it. So that, but now with the tools that are available, it makes the job easier for the teacher as well as the learner. Very quickly, somebody can learn, what is a parametrical kind of design into that. And not only somebody can design, they can do simulation, they can do the testing completely into that, using the simulation into that. Today, something like an MSS is there, mechanism system simulation that is there. Using that, somebody can test it. So with the result, like in fact, it gives a very good experiential learning. Those days we could not experience, but that today, in fact, thanks to various technologies and learning tools that are available, it is very easy to get experiential learning, sir. Sir, you are muted, sir. Mr. Kalyan Raman, you are muted. I think you have to. Yeah,
thank you,
yeah.
thank you. So Dr. Ramarao Gollamadi, he's looking at something we've not yet discussed: teaching of English in the engineering first year, teaching of English communication skills in a four-walled classroom. That's not effective, he's saying. Well, yes, they will get better skills if they're given a choice to pick up any book of their liking and giving a presentation with 10 minutes in open classroom rather than a defined syllabus or textbook. How should English be taught, sir? Differently from what we've seen so far.
Sir, teaching has to be done in the four-wall classrooms. We cannot go to the outside ground and teach. Four-wall classrooms is required. And today, a lot of softwares are available to learn how to present. And even the student can be asked maybe 2 times or 3 times in a semester to give a seminar to his only friends. That is what to express his views. So methods are changing. Probably what he meant is it's not one-way traffic. Student also should be able to speak and express his views, and that is okay. And nowadays, colleges, some of the colleges are implementing that in the class. They have the tables, 10 people together. They do a combined one and develop some PPTs, etc. And somebody will go and present. This is what is required. And in the language teaching, a lot of tools are available today. Those tools have to be used, that is listening comprehension and speaking comprehension, and similarly different kinds of cultures a student has to understand by going through the softwares, and will be able to get updated with what is going around.
So just to add to that, sort of nowadays, like in fact, the English communication is not generally not taught, in a four-way classroom into that. Today there is something like English language labs are there. the labs that are there, they take care of all these things, something like, speaking, learning, and sort of, writing various aspects of that. Today, they are all more of them, like, AI adaptive labs are there. To that extent, depending on the individual, all of us are not born alike, like when they come to the college, like our language skills are not same for all of us. Particularly in the case of, the communication kind of, English language, in my view, today AI come in very handy into that. Looking at the individual, like the AI can give you what is called an adaptive learning tool, so that maybe I may be strong in verbal, I may be very poor in something like other communication into that. So there, when once somebody goes through the AI kind of driven language lab, like it is more of a self-learning which is guided by the faculty into that. Today, as a matter of fact, something like various universities like Oxford, sort of today they have set up labs in India. They come and help the engineering colleges, on how to teach language skills. So much so that something like they conduct various tests. Today, language kind of teaching and training has come a long way, not only with regard to the English labs. Today, added to the AI, AI kind of help a lot, with regard to self-learning and guided learning as per the pace of the student, and continuously student can see how much I learned and what more I have to learn, where I go. Because a student, must be encouraged when they go through some learning. So as a part of the evaluation, continuously student will know sort of, what is my improvement. I think that is something that, they can make use of.
Point taken, sir. Yes, language teaching, there's plenty available that
Absolutely.
engineering colleges can leverage than just, trying to
Yeah.
teach it on their own. Yes. Motahar Raza, he's another question is we sort of dealt with it before, but I think it's worthwhile flagging it. Should core mathematics courses in an engineering curriculum be taught by mathematics faculty or by engineering instructors? For instance, discrete mathematics is typically taught by computer science faculty at the IITs and NITs, yet most other universities assign it to their mathematics departments. Which approach is more effective?
Because I feel I'm not the right person to answer this because I'm not a discrete mathematics person. But one thing is, whoever is using the discrete mathematics principles in engineering, it is better that subject is taught by them. As indicated earlier, mathematics people are not able to bring in the application, whereas the discrete mathematics is computer scientists use, they take the examples and explain better. In that way, if mathematics department has the difficulty, computer science people can teach the discrete mathematics.
Sir, I can add to that, coming from the IT background. Today, what happens is, particularly for the computer science students, and more so for the AI/ML students, what they need is not simple mathematics. It is application of mathematics with regard to the design of algorithms into that. So if they got to do that, sort of, I fully agree with the professor when he says that, possibly the computer science PhDs, they are better suited to teach that rather than a pure mathematics professor. I'm in full agreement with him into that, Today, lot of kind of, we have got, the PhD computer science students that are there. They come with very strong mathematics and a mathematics that is relevant to the computer science. Today, if you take something like, you take, the AI, the various kind of, the learning that goes into that, like you take a reinforced learning, you take it, or you take any of the AI that is there into that, it's full of mathematics into that. So that's where definitely it is a computer science faculty, like, who is better equipped to teach that rather than a pure mathematics. Because unfortunately, what happened in India is the pure mathematics kind of teachers, they don't have exposure to computers. They may
So
use certain tools, but other than that, the computer science, the kind of, the familiarity in the interface is relatively less. So I think that is my view on that.
Sir, to add to that, I did my MTech at IIT Madras. Mathematics at the MTech also was there. Mathematics was there. And at the time, mathematics people used to teach that mathematics courses. When we grew up after 10 to 15 years, and there are quite a good number of people with a good mathematical background, we told postgraduate mathematical tools have to be taught only by the engineering because they come with the applications. We don't require the pure mathematics, we require the applications. It so happened my course of computational methods, MSc students, those who pass out the MSc, sitting in the class, they used to find it difficult because you take the practical problems and how to apply mathematics. They don't have the visualization of the practical problems, they used to find it difficult. That way, at the higher level, it is better the specific branch people will take the application problems and teach that subjects.
Okay.
So just added to that, another branch of mathematics where there are practical problems is with regard to the probability and statistics. So we have seen in our own kind of university when I was the vice chancellor, we had the best of the faculty coming from the statistics to take classes. There also we had the problems, we had the challenges because the statistics and probability that is required for the engineering students is not a pure statistics. It is application of the statistics into that. Similarly, we have seen in the case of management also. Like, the statistics has to be applied and probability has to be applied in a real life situations, like the pure play statisticians, they were unable to relate with the practical examples. So that's where I think, they need to be groomed into that, Otherwise, today what happens is, like, if you take for the kind of a students of, either engineering, otherwise, risk management, they need to understand a lot of, statistics and probability. And how many of our statistics to faculty can teach risk management? So to that extent, I think, I agree with you that, one, the so-called the pure sciences, kind of, the faculty, they have to go through some kind of immersion into the other disciplines. So that they need to go through some interdisciplinary kind of learning, so that they'll be able to relate to the application of that pure science into that, be it mathematics, be it statistics, or be it physics, or be it chemistry. I think that is very critical for all the pure sciences faculty members.
Okay, we're winding down with, here's another contrary post, question, comment. Venkata Ratnam K, he's saying for major engineering related problems, the solution is available at the root of science. The best example is the Apollo space disaster. I think he's talking about the fire, not the second one. The fire where it was oxygen rich and it caught fire, and then they sort of inerted it with nitrogen, I suppose. I think he's referring to that. So, well, science is based, engineering is based on science. There's no denying that science should not be taught, but we were just looking at how it should be taught. But he's saying Applied Chemistry by H.T. Gesser is one of the best books to understand problems in engineering in the field of science. Point taken, sir. But I think what we've all said, and many of those who've asked questions, and as well as the panelists have said, some kind of relation to practical problems in engineering would serve the teaching of science. Just to give a personal example, when we were learning all the matrices extensively, we learned matrices across engineering, and you wonder, why are we even learning this? What is the point of these eigenvalues and eigenvectors? And suddenly the maths teacher said, he was talking about how this is many years ago, and he was talking about how this is used in the fabric industry. He was talking about how colors are being, computer simulation and matrices being used to simulate and see what colors are the output. And that sort of it sparked something and made us realize that these are all practically important. I suppose we have to end this webinar here. We've taken 20 minutes more time, but it was worthwhile. Lots of interesting questions, insights. I do ask all those who posted questions to send an email, to either post an email ID here or send an email to education@thehindu.co.in. We will certainly consider you for free access to the Hindu online, based on what the panelists tell us and how important these questions were. Thanks, everyone. Thanks, sir. Thanks. We thank the panelists also for joining in. It was very interesting, insightful. Until we meet again next Saturday for another education webinar. Thank you, sir.
Thank you very much, and have a nice weekend to all of you.